Okay, so today's lesson we're going to focus on nets of 3D objects. We will look at making a net from a 3D object and then predicting what 3D object we have from the net. But before we get to that, I'd like to review some vocabulary regarding 3D objects. When we describe a three-dimensional object, so here we have a rectangular prism, there's a few terms that I would like you to know. The flat or curved surface, so here we have like the front surface, the top, we have the back, the bottom, the left and the right, so that's the flat surface in this case. That's called a face. And then where two faces meet, so this top face, this front and top face, where they meet, so this line right here, so they both meet here, and the front and the right side, they meet right here. So the line segment where two faces meet, that's called an edge. And then if we have three or more edges, so this edge right here, this one and this one, so the point where three or more edges meet, that's called a vertex, and vertices when we're talking about more than one. Okay, so what I'd like you to do is pause the video, go find yourselves a rectangular prism, like a Kleenex box, or even a book would work for this. And I'd like you to count how many faces, edges, and vertices it has. So a rectangular prism then we've got the front, the top, the back, the bottom, the left side, and the right side. So it has 6 faces. And then the edges, we can count them, and we have to visualize the ones we can't see. So we have 2 on the top here, 2 on the bottom, 1 in behind. And then, so that's 4. And then we have 1, 2, 3, and the one behind. Then 1, 2, 3, and the one behind. So we have a total of 12 edges. And the vertices, or the sharp points, we have 4 on the top and 4 on the bottom. So for a total of 8. Okay, so the next portion here, a net is a 2D shape that when folded becomes a 3D object. So we're going to draw nets for these three-dimensional shapes by visualizing what would happen if we cut along some edges and flattened them out. So a 2D shape is essentially a flat representation of the shape. Okay, so this first one here is a rectangular prism, and what I did was, for this one I found a rectangular prism, cup of soup, and I cut along some of the edges so that when I flatten it out, I don't know if you can see that. Yeah. So when I flatten it out, here are my 6 faces, right? So the top, the sides, the front, and the back. Okay, so what I'm going to do now is draw this out. Okay, so this rectangular prism has 6 faces, and the top and the bottom are the same size. The front and the back are the same size. And this will become important in our next section. And the left side and the right side are the same size or the same shape, same dimensions. So left side LS and right side same size. Okay, so moving on to our next 3D shape is a triangular prism. So a triangular prism, we're going to draw a net for it. So imagine cutting along some edges, flattening it out. I was able to find these at our school. So here I have a triangular prism, and you'll notice it has 5 faces. So the bottom, the left, the right, and the front and the back. So the front and the back are triangles and the other ones are rectangles. So we have 2 different shapes. So let's see what happens when we cut along the edges and flatten it out and find the net. So here are our 3 rectangles and our two triangles. So let's draw that out. And when you're drawing out the nets, it has to be, you have to be mindful of where you're placing the shapes as well. So I can't have 2 triangles on this side here, right? I cannot have the triangle here and here. They have to be somewhere along the lengths, along the sides here. So the triangular prism has 5 faces, and 2 of them are triangles that are the same size, so they have the same dimensions, and that once again will become important next section 2.3 when we're calculating the actual surface area. And then it has a triangular prism has 3 rectangles, and their sizes can vary depending on the triangular prism itself. And then our third shape is a cylinder. So imagine a soup can, for example. So I'm just going to, I found a cylinder at school as well. So I'm going to imagine flattening it out. So you'll notice it has 2 circles and a curved portion. And if I flatten it out, I end up with a rectangular portion and 2 circles. So 3 faces. So we can draw that out. So a cylinder has 3 faces, 2 circles that are the same size, and 1 rectangle. So those are the 3 shapes that we're going to be focusing on when calculating surface area and also volume. Okay, so in example 1, we have a can of paint that has a diameter of 10 centimeters. So the diameter is the distance across the middle of the circle. So that's 10 centimeters. And it has a height of 13 centimeters. Okay, so where was I? It has a diameter of 10 centimeters and a height of 13 centimeters. And we want to draw two different nets for the can. So visualize what the can would look like if you could cut along the edges and roll it out, right? And I'd like you to label the measurements. So if we were to take the cylinder and roll it out, we would have one circle on the top, one circle on the bottom, and labeling our measurements. So this here, the height is 13 centimeters. And our diameter for the circle is 10 centimeters. So that's one net. If we wanted to draw a different net, we could put the circles, they have to be on opposite ends, but they could be the same on the same part. So so I'm drawing it vertically here, so that I took the paint can, put it on its side so that this is 13 centimeters, and the two circles here, this diameter is 10 centimeters. Okay, so example 2. Draw a net and label the measurements for the rectangular prism. So it looks like we have a similar to a Kleenex box, for example. So what we'll do is we have to be very careful with our measurements when we're labeling them. So let's start. I'm going to start with the top here and work my way to the front, and then the bottom, and then the back. So I'll start by drawing the top. I'll just put a little circle in it. Then I'm going to draw the front. So the front is also a rectangle, but it's shorter. Then I'm going to draw the bottom, which is the exact same size as the top. So it has to be the exact same size as that. And then the back, which is the exact same size as the front. So as this one here. Okay, and now for the sides. So I have the left side and the right side. I'll have them coming off the top. And there's my net. So looks like, I feel like I did a pretty good job. And now what I need to do is label the measurements. So let's see. So this is 25 centimeters. All of these are. Okay, and starting with the top, this part here is 10 centimeters. So same on both sides. So the top and the bottom are the same. That makes this one 10 centimeters and this one 10 centimeters. Our front here has a measurement, a length of 7 centimeters. So that would be the same for the back. And what else do I have left to measure here? Oh, so it looks like I've done all of the rectangles except for this here. So this is 10, and this one here would be 7 centimeters. Okay, so that's an example of drawing a net and labeling the measurements. And then in example 3, we want to match each solid with its nets. So you can pause the video here, see if you can match them up.